In this video for section 8.1, we're going to introduce the idea of a confidence interval. We're going to look at this example with the HealthStar energy drink. They make a drink that's sold in 12-ounce bottles, and the manager in the quality control lab selects a random sample of 100 bottles, measures the volume of liquid in each. They find a sample mean of 12.79 ounces. We're going to assume that sigma, our population standard deviation, is known to be 0.2 ounces. So we can say that the value of 12.79 ounces that we found from the sample mean is the best guess for the population mean mu, the population being the volume of all bottles produced by the company. So we could also call this a point estimate because it's a single value. 12.79 is a single value that we can use to estimate the amount that is in each bottle. If we take a different sample of 100 randomly selected bottles and found their mean fill amount, would we expect it to be exactly 12.79 ounces? Well, no, we wouldn't expect to get exactly the same value if we were using a different sample of bottles. It probably would be somewhat close to 12.79. It might be like 12.85 or 12.6, but we would not expect to get exactly 12.79 ounces if we were taking a sample of different bottles. And this variation from sample to sample is called sampling error. The word error is a little bit misleading because it makes it sound like it's a mistake that you're making. It's not a mistake, it's just a natural thing that occurs when you're looking at different samples. Different samples are going to come up with slightly different results. So one thing that we can do is we might not want to rely on a single value or the point estimate. We might rather produce a range of values that most likely includes the parameter being estimated. So we could say that the population mean is between these two given numbers. And this range or interval is known as a confidence interval. With each confidence interval, there is an associated confidence level. And the confidence levels that we're going to see in this class are 90%, 95%, and 99%. As confidence level decreases, the interval gets smaller or narrower. So you might say that you would rather be 99% confident in something than 90%, but if that's the case, the trade-off for that is that your interval is wider, or in other words, there's a greater range of numbers for your possible mean. So for the problem above, if we use Minitab to find the 95% confidence interval estimate, we find that it's 12.75 to 12.83 ounces. So what this tells us is that if the bottles are supposed to be filled with 12 ounces of liquid, the machine is probably not working because we're 95% confident that the mean value of all bottles is between 12.75 and 12.83. So a lot of times with these problems, when you're doing the interpreting part, you're going to be looking to see if the value that you're looking for is contained in the interval. In this case, it's not because 12 is not between 12.75 and 12.83. If the interval did contain the value, then that would tell us that the true population mean could in fact be exactly 12 ounces. But since it's not, we would say that it's unlikely that the true population mean is 12 ounces. Now, when we're interpreting confidence intervals, it's important that we can interpret them correctly. So if we have a 95% confidence interval, then this means that if we were to select many different random samples of 100 bottles, approximately 95% of the intervals that we would calculate from those samples would contain the true population mean. So this graph image here illustrates this. It says proportion, but it works the same for means. If the green line here is our population mean that we're looking for, if we're 95% confident that the interval contains the mean, then that means that if we were to take 20 samples and construct 20 different intervals, 19 of the 20 would contain the true population mean. One of them would not. And so if you look at this image, you see this one right here does not contain the true population mean, or the green line. All of the other intervals, 19 of the 20, do contain the green line. Some of them just barely, like this one, but they do contain the green line. And so 19 out of 20 would give us 95% confidence. Now the second page here is really important for when you're actually constructing these in Minitab. You need to pay attention to whether the population standard deviation is known or if you're using standard deviation estimated from a sample. If you're using population standard deviation, then that means your calculation is based on the normal distribution. In Minitab, this is called Z. And so what you're looking for in the problem is if you see the words population standard deviation or the sigma symbol, then that tells you that you're going to use Z in Minitab because you have a known standard deviation or a population standard deviation. If the standard deviation is not known, then it's based on a different distribution called the t-distribution, not the normal distribution. The t-distribution is similar to the normal distribution, but it's a little bit different. Sometimes it's called the student t-distribution, but in Minitab you will see just the t-distribution. And so when you're using t is when you have the sample standard deviation, or the standard deviation is referred to with the letter S. So it's really important when you're doing the problems that you identify which type of standard deviation you have. So let's look at example 8.1. Administrators at a university are interested in estimating the average amount students spend on textbooks during the first 4 years. They take a random sample of 200 students, and they find a sample mean of $5,230. Past studies have indicated that the population standard deviation is $500. Find a 90% confidence interval for the population mean. So, in this problem, they're telling us the population standard deviation. So that means that we are going to use Z in Minitab. We have our sample mean of 5,230 and our sample size of 200. And we want to find a 90% confidence interval. So let's go to Minitab. We're going to go to Stat and Basic Statistics. And then you see the options here in the second box for one sample Z and one sample T. This one I have population standard deviation, so I'm using one sample Z. I need to change this first drop-down box to summarize data. And then I can enter the values for sample size, sample mean, and known standard deviation. So my sample size is 200, my mean is 5,230. And my known standard deviation was $500. And I want to find a 90% confidence interval. So once I enter the standard deviation, then I click on Options, and I can change the confidence level here to 90. This alternative hypothesis box you're just going to leave alone for now. And click OK. And here's my interval, $5,171.80 to $5,288.20. And remember, if you need more digits after the decimal point, you can click on the box to highlight it, and then click on the drop down to change the number of decimal places displayed. So this is the interval that I would enter if this were a homework problem. I'll write it down here, 5,171.8 to 5,288.2. So I'm 90% confident that the true amount, the average amount that students spend on textbooks for all students at the university is between these two numbers. Now let's look at example 8.3. We have an auditor for a grocery store, and they are interested in the difference between customer bill and true cost of the items. We have a sample of 20 transactions, so that's my sample size. Sample mean of 77 cents. And standard deviation of $1.19. We want to find, again, a 90% confidence interval. Now for this one, I don't see the word sample or population in front of the word standard deviation. However, when it's phrased this way, sample mean and standard deviation, we can infer that this is referring to the standard deviation of the sample. And so we're going to use T for this problem. So we're going to go to Minitab, and now we're doing one sample T. Again, I need to change this to summarize data. Now I'm entering my sample size, sample mean, and my sample standard deviation. So my sample size was 20, sample mean was 77 cents. And my standard deviation of my sample was $1.19. We want to find a 90% confidence interval. So click on Options and change this confidence level to 90. And then click OK. So my 90% confidence interval is 31 cents to $1.23. And so what this is telling me, again, is that I'm 90% confident that the true difference between customer bill and true cost, that true difference is between 31 cents and $1.23.